So another way you could find the graph of a parametric function is by eliminating the parameter. So that's basically taking a parametric function and writing it in terms of just x and y, which is what we're used to. So in order to do that, you'd have to solve one of the functions for t, and it says if possible, because again, it's not always going to be possible. And then we substitute that function into another one to get the function just in terms of x and y. So if we look at the last example that we just did, which we already know what the graph of it is, it's that sideways parabola. We had our two functions, x equals t squared minus 2t and y equals t plus 1. So we'd have to solve one of these for t, and the only one we can do that for is the second one, because the first one we have a t squared and t. We can't get t by itself, but here we can. So we get t by itself by subtracting the 1 over, so t equals y minus 1. And now we could substitute this in for t in that original equation with x. So we'd have to substitute using parentheses. We get the quantity y minus 1 squared minus 2 times the quantity y minus 1. And if you do some foiling, distributing, combining like terms, you end up with this quadratic function. But this is a quadratic x in terms of y. Okay, so the y is being squared, which means it's going to be a sideways parabola, which is exactly what we already saw when we sketched it using our point plotting method. Right? So again, you could change your parametric function into a regular function and then find the points that way as well. This would be a little trickier though, because you don't necessarily have the order of the points. You don't have that direction that we have from the last one when we graphed it using the points, all right, the t values. Another interesting graph that we can see in parametric mode that can be graphed pretty easily in parametric is your unit circle. All right, so when we did unit circle values, we said that the cosine of theta were your x coordinates and sine of theta were your y coordinates. So that could easily translate into a parametric function. So this parametric, x equals cosine theta, y equals sine theta, where theta is in radians, okay, would give you one route around the unit circle, or one path moving in that same direction, that counterclockwise direction. Right. Now this one we're using theta as our independent variable instead of t, but it doesn't make a difference. If you use t here or theta, it's the same problem. All right, it's just we tend to use theta when we're using angles instead of t. But if you graph the function, you actually end up getting your unit circle that goes in your counterclockwise direction from that point 1, 0 that we start at. Okay, so as theta increases, we move along this path. So we actually start by moving up and to the left, then we're moving down and to the left, then we're moving down to the right, and then we're moving up and to the right. All right. So all those different types of motions, those are a lot of motions that we find in calculus when we start to take derivatives of parametric functions, and we can answer those questions without actually even seeing the graph. All right, we can figure out when a particle is moving up, down, left, or right just using the calculus. All right, but for now, we're just going to focus on what is a parametric function and how do we graph it. So when we move on to the next video, we're going to look at the different ways to graph it. Actually, we can list that now. So the 3 different methods we have for finding our path, and then we'll do the calculator example. So the first one is the way we did it the first time. So plotting points for various values of t. If they restrict t in any other way, you would do that. Usually we use whole numbers for t. It's just easier to find. And again, it says what values of t should we assume if not given a specific domain. The second way we could graph a parametric is to eliminate the parameter and then find one equation relating x and y and just graphing it the way we've graphed all x and y functions. And then the third way, which we're going to do in the last video example, is to use the calculator, all right, in parametric mode, setting up correct windows and seeing your order and then being able to trace it out. So all these 3 different techniques are how we could sketch the path of a parametric.